Welcome to this video on the hardest P2 questions from 2022. It's actually the June 22 paper and the October 22 paper. If you like these kinds of videos, of course, subscribe if you haven't done so already. And if you're a long time viewer and you wish to help me out, just please consider becoming a member. If even only for a month, just if you feel like you're able to give back a little bit to me, then that would be mostly appreciated. Anyway, let's get into the video. So this is question 2 on the June 2022 paper. The Chief Examiner reports that Parts A and B were scored quite highly, but marks were rarely awarded in Part C. So let's get into it. We'll do Parts A and B, just normal. That shouldn't be too much of a problem for people. And then we'll look at Part C. Now, Part A is just simply using your calculators. So if we look at this bit, the y equals 1 minus log 10 sine of x. Now, in my calculator, when I try and type it all in one go, it comes up with an error. I don't know why, but so I've had to just type in the sine of x first to get the value for it and then substitute it in. So you may have to do that as well. I'm not sure, but might just be my calculator. But anyway, so I'll put the values in. So this value is 1.075 to 3 decimal places, rounded to 3 decimal places, and then this one is 1.041. Okay, so it's an easy 2 marks. Now, Part B is use the trapezium rule. So Part B now is the trapezium rule. So we've got to do between 3 and 0.5. We're estimating this. So h is, b minus a over n, but it always works out to be the difference. So this is what it's going up in. So it's going up in halves. So h is 0.5. over 2. And then we've got to look at what we put in our brackets then. So it's going to be this value and this value, and then double these values. So 1.319, 1.319 plus 2 lots of all the values in between. So 1.075 plus, I'll just make a little bit of room here. Okay, 1.001, 1.041 and 1.223, and then plus the end value 1.850. And then putting that into the calculator, I get 2.96225, which is 2.96. Now, this kind of thing, unless it does tell me here to 2 decimal places, so that is good. But in terms of accuracy, if these are all rounded to 3 decimal places, then this will be accurate to 2 decimal places. Okay, so using 1 additional decimal place in your working out will always give you that accuracy there. Now let's have a look at Part C, because this is where there were hardly any marks given. So let's look at what we've got. We've got between 3 and 0.5, so the same range of values, and we've got 3 plus log 10 of sine x. Now, up here we've got 1 minus log 10 sine x, and here we've got plus. So first thing I'm going to do, I'm just going to deal with this at the moment. Okay, so 3 plus log 10 sine x. Now if I take a minus 1 outside, then this will change to minus 3 minus log 10 sine x. Yeah? Just by taking that minus 1 outside. Now we're almost at this stage. We want 1. So how can we have 1 here? Well, we've got to add 4. But this is really what we're doing, is taking away 4. So we have to add 4 in here. And that gives us 4 minus 1 minus log 10 sine x. Another way to look at it, if I rub that out, again starting with 3 plus log 10 sine x, is doing this right. I'm going to take away 4 from here. So I'm going to take away 4 and I'm going to add 4. So this gives me 4 plus minus 1 plus log 10 sine x. And then I'm going to take out, because I've just taken away 4 from here, added 4 there. Then I'm going to take out minus 1 outside the brackets. So 4 minus 1 minus log 10 sine x. So that's another way of looking at it. But either way, then we get that this is equivalent to 4 minus 1 minus log 10 sine x dx. Let me just rub that out down the bottom. So now we can separate out our logs. So this is log of, not log, integrals. This is integral of 4 dx minus the integral of 1 minus log 10 sine x. And that is 4x, integral of 4, between 3 and 0.5, minus 2.96, which is our answer to part B. So we've got 4 times 3 minus 4 times a half minus 2.96. So that's 12 minus 2, which is 12 minus 2 minus 2.96. So 10 minus 2.96 is 7.04. And that is the final answer there to part C. So it's just a little bit of like manipulation. And don't be surprised if like something like this comes up. It's early on in the paper, so this they were expecting the majority of people to be able to answer, and unfortunately very few people did. So that's 3 marks just following my method here, that you can get in future. Okay, question 6 is the next question. It's attempted by all students, but it did discriminate between the candidates according to the examiner. Part A, was done reasonably well in some cases, but not all. Part B usually scored 1 mark. Examiner notes because the quadratic, solving the quadratic, most candidates have calculators with the ability to solve the quadratic, so they scored 1 mark, but then they ignored the wrong value, so you get 2 values out. A lot of candidates then ignored the wrong value moving forward, and then couldn't do part C either. So let's have a little look at it. So it's geometric series, so it goes up AR squared, AR cubed, and so on. So the second term, U2, is AR, and the third term, U3, is AR squared, because it's ARn minus 1, and U4 is AR cubed. So we've got 2 bits of information here. So U2 and U3 equals 6. So AR plus AR squared equals 6. And AR cubed equals 8. Now with this first one, I can factorize out A. I can factorize out AR, in fact, if I rub that out, let's take out the AR. 1 plus R equals 6. Now, if I divide these two, I'm going to get rid of the A's and just leave me with R and a number. So AR cubed over AR1 plus R is 8 over 6. So the A's will cancel, 1R will cancel, so that leaves me with R squared over 1 plus R equals 8 over 6. 8 over 6 could have been actually 4 and 3. So let's put that as 4 and 3. So R squared, so 3R squared equals 4 times 1 plus R. 3R squared equals 4 plus 4R. 3R squared minus 4R minus 4 equals 0. And that is what we needed. So that's part A done. Now, part B says find U1, which means find A. So for that, we really need to find out what R is. So that means solving this equation first. So this gives me R and 3R. R minus 2 and R plus 2. And that gives me 3R squared, 2R minus 6R is the 4R, minus 4R, and that gives me minus 4. So R equals 2, or R equals minus 2/3. And next we have to choose which value of R. And a lot of people chose R equals 2 because it's positive and ignored this one. However, we've got this sentence here. And it says that given the geometric series has a sum to infinity. If it has a sum to infinity, it means that R is less than 1. Yeah, so that means that R is between 1 and minus 1, which means R equals 2 is not our value. R equals 2/3 is. And that bit of information is key, and so many candidates overlooked it. Okay, then we've got our R4, which is AR cubed equals 8. So A times minus 2/3 cubed equals 8. So minus 2/3 cubed is minus 8/27, and 8 divided by that would give me minus 27. So that is my A, which is also my U1. Next we have to find our sum to infinity, which is the formula A over 1 minus R. So it's minus 27 over 1 minus 2/3. Which is minus 81/5. And that is it. So very straightforward question, but the first part, a few people didn't realise how to get to the answer, so hopefully you can see that now. And in the part B, it's noticing that sum to infinity. Now I know in an exam there is obviously some pressure. At this point, question 6, you're just over halfway through the exam. It is easy to miss these things, but when you've got two answers, so R equals 2 and R equals minus 2/3, there's got to be a clue in the question as to which answer you will use. So at that point you should scour the question for some information. Okay, so that will be a clue there. Right, on to the next one. Okay, question 9. So the chief examiner notes that the sketching of the exponential graph was done very poorly and full marks were rarely attained. So that was part A. Those that did succeed in drawing it often failed to state the y-intercept or appeared to think the asymptote of the graph was above the x-axis, and many scored no marks here. Part B showed that candidates were not familiar with this type of question, as the question only stated that the initial amount had halved, but there were no values given. Okay, one approach was to substitute numbers, which often led to the correct equation, but once candidates arrived at the second equation, a surprising number of candidates used log work to arrive at the given result, which was not as efficient as taking the root. And then it says generally parts C and D were best answered in this question. That said, some candidates were unable to write down the correct equation, which in themselves were fairly straightforward to solve. Let's see here, part D. So I think that's it. Let's have a look at this question then. So here's the graph of the equation of what we're going to be sketching. N equals K lambda T. And it says sketch graph of N against T for K equals 1. So we're sketching N equals lambda T. So that's an exponential graph, which you would assume went like this, but tells me here, when I look at it, we look down here, lambda is between 0 and 1. So lambda is, a decimal value between 0 and 1, and the graph of that is that way. So that's where I've got a sketch. So I will build it up. So something like this is my graph. That's 0. That's going to cross at 1 when t is 0. This is t. No. This is n. This is t. So that's the graph there. This part on the left, I suppose you don't really need because t is time and we can't have negative time. I've left it in there, but you can ignore that. So that will give me the full 2 marks here on this question. Now let's look at part B. So we've got part B, n equals k lambda t. And looking up here, k in grams is the initial amount of carbon 14 present in the item. So it takes 5,700 years for carbon 14 to reduce to half its initial value. So if its initial value is k, half its initial value is a half k, and that equals k lambda 5,700. The k's will cancel, so lambda 5700 equals a half. Now you can use logs, but as I said, if this was like y squared equals a half, you'd just take the square root, wouldn't you? Or if this was y cubed equals a half, you just take the cube root. Now it's y to the 5,700, so we take the 5,700th root, and that equals 0.999878426, which to 6 decimal places is 9998786 dp. Now, part C, you don't need to have done parts A and B to be able to answer it. So that is why, people generally couldn't do parts A and parts B, and then we're able to start at C. So here we've got 15 grams of carbon 14, so n equals k lambda t, and in this case n equals 15 lambda t, and we know our value of lambda is that there. So it says here is thought to be 3,250 years old. Calculate the 3 significant figures how much carbon 14 the equation predicts. So that is now 15 times 0.999878 to the power 3250, and that gives 10.0898 or 10.1 grams. Now item B is known to have initially had 25 grams, but now only 18 grams remain. Use algebra to calculate the age of item B. So we know it's n equals k lambda t. We know that n is 18 grams. It had 25 grams to begin with. 9878 to the power t. So first things first, 18 divided by 25, 0.72. And then there's a couple of ways of doing this. Personally, I just take logs of both sides. And bring the t down. So that becomes t there, and then t equals log 0.72 divided by log 99 whatever. So that divided by log 0.999878, and that gives me t is 2692.49 and so on. Now we've got to round it to the nearest 100 years, so it's 2700. Obviously at this point you could have done that t equals log of the 0.999878 of 0.72 and solved it that way, but I just personally find taking logs of both sides just easier and a little bit quicker. But anyway, that's part D done. C and D were pretty straightforward anyway, and now you can see parts A and B there. They're only worth 2 marks each, but you know, sometimes these little marks will make the difference to your grade or the difference to your overall UMS. And obviously trying to get the biggest UMS you can on these papers, making it easier, you know, when you have a hard paper in upper 6, then, you know, P3 or P4 paper, you can afford to score a little bit lower but still get the grade you desire. Now, final question in the paper. By this point, you know, a lot of candidates will be potentially a bit fatigued, you know, right at the end of the paper. Now, the chief examiner notes that this question was generally answered poorly, with many candidates unable to proceed beyond part A. Okay, so many candidates unable to go beyond part A. Part B was not answered as well as part A, and part C was often left blank or with minimal aborted attempts. It was not clear if this was a timing issue or if candidates simply did not know how to tackle the problem. So that's a gist of what the chief examiner thinks. Now let's have a look at the question and see what you guys think. So we've got a circle with centre 3, 5 and radius r. So using the equation of the circle, there's x minus 3 squared plus y minus 5 squared equals r squared. And then we've got another equation where y equals 2x plus k. Now, we've got to show that L and C intersect when, and if I look through this equation, I've got x's, I've got k's, and I've got r's. I've got no y's. So if I substitute this y into here, because that is when they will intersect, it'll give me x's and k's, x's and r's. So that is what we're going to do. So x minus 3 squared plus 2x plus k minus 5 squared equals r squared. Now I need to just expand my brackets, so square the first, double the product, square the last. With this one, I'll use the k minus 5 like as a single term there. So square the first will be 4x squared, double the product would be 4x times k minus 5, and square the last will be k minus 5 squared. Now I've got to expand these brackets, so x squared, we'll do a little bit of tidying up, and the 4x squared, that will give me 5x squared minus 6x plus 9 plus 4xk minus 20x plus k squared minus 10k plus 25 minus r squared equals 0. So we've got 5x squared. Now we've got like the x term here. So we've got minus 6x and minus 20x. So that's minus 26x. I'll do it in 2 steps. Plus 4kx, 9 minus, oh no, that's minus 10k. So we've got plus k squared minus 10k, 25 and 9 gives me 31 r squared. Now, what am I thinking? 25 plus 9 is 34. Now we need to factorize out the x, so 5x squared plus 4k minus 26x plus k squared minus 10k plus 34 minus r squared equals 0, and that is then what we require. Okay, so we've done that. Now part A is done. Now we're going to part B. Now given that L is a tangent to C, that means that b squared minus 4ac will be equal to 0. There's just the one root. And here's my A, my B, and then this is my C. So b squared is 4k minus 26 squared minus 4 times 5 times k squared minus 10k plus 34 minus r squared, and that equals to 0. So let's expand our first bracket. So 4k squared would be 16k squared. Now 26 times 4 is 104, doubled is 208, so minus 208k plus 26 squared is 676. Now we've got minus 20, like minus 4 times 5, minus 20, so minus 20k squared. Minus 20 times 10k will be plus 200k. Minus 20 times 34 will be minus 680, and minus 20 times r squared will be plus 20r squared. So let's deal with sorting these out. So 16k squared minus 20k squared is minus 4k squared. Minus 208k and plus 200k is minus 8k. And then 676 minus 680 is minus 4, and then we've got plus 20r squared equals to 0. So 20r squared equals 4k squared minus 8k minus plus 8k plus 4. Now if I take the 4 outside the brackets, I factorise out 4. We've got k squared plus 2k plus 1. And dividing by that 4 gives me 5r squared equals k squared plus 2k plus 1. So I've almost shown that, as that is k plus 1 squared. So far there's been quite a lot of algebra manipulation in this. Quite straightforward, but you know, when it's at the end of the exam and you're quite tired, I can see why some people were unable to do this, but it's been quite straightforward really. Now part C, we've got to find the value of k. We know that this 5r squared equals k plus p squared. That's going to be when these two intersect, so that's going to be at B. So this 5r squared equals k plus 1 squared is at B. And we know y equals 2x plus k. So at A, x equals 0, so y equals k. So the point A is 0k. And we also know that if it's a tangent, it's a right angle there. So we know that's happening there, that AXB is a right angle triangle. AB is 2R. Okay, so that's what we've got so far, and that is R. So that's 0k. So we can deal with this as a right angled triangle. So that would be AB squared plus BX squared equals AX squared, the hypotenuse. So AB squared is 2R squared. BX squared is just R squared. And AX is, right, so I'll do squared brackets here. Squared. So it's going to be 3 minus 0 squared plus 5 minus k squared, and that then square rooted, but of course that's all squared. So we've got 4r squared plus r squared equals 3 squared plus 5 minus k squared. So 5r squared equals 9 plus 25 minus 10k plus k squared. So 5r squared equals k squared minus 10k plus 34. But 5r squared equals this, k plus 1 squared. So this equals k plus 1 squared. So that equals k squared plus 2k plus 1. K squared will cancel. It gives me 12k on this side equals 33. So k equals 33 over 12, which is 11 over 4. Again, I don't think it was too hard, but it was quite hard to spot that this was a right angle triangle, maybe. I don't know if there's another way of doing part C. Don't know, maybe with the gradients or something. Not sure. There may be another way. Let me know if you find another way of doing part C that's like easier than the way I've done it. But yeah, that's the June 2022 paper, hardest questions complete. Yeah, not too bad in general. So this is the October 22 paper now, and we've got a couple of questions to look at, 3B, 5B and question 10. Now 3B, there seems to be a significant number of candidates who are confused by this question, leaving it blank or nearly blank, likely not due to not understanding how to deal with the square of the trigonometric ratio. Part B was less accessible than part A. So part B was the biggest problem, but I think looking at what the chief examiner says, part A was equally quite challenging. The finding the exact values as well was another area where, you know, evaluating the terms and getting the exact values, it wasn't done very well. So let's have a little look at it. We've got a sequence, A1, 2 and 3 and so on, is defined by AN equals cos squared n pi over 3. So A1 is cos squared pi by 3. Now this just means cos squared pi by 3 is just cos pi by 3 squared. Now pi by 3 is, 60 degrees. Cos of 60 degrees is a half. Also cos of pi by 3 is a half. Putting your calculator in radian mode there. So this is 1/4. So that first one, fairly straightforward. A2, so that is cos squared of 2 pi by 3. Or cos of 2 pi by 3 all squared. So 2 pi by 3 is 120 degrees, because pi is 180, isn't it? So 180 over 3 is 60 degrees, times by 2, 120 degrees. So cos of 120 degrees is minus a half. So it's minus a half squared, or 1/4. And then A3, so this is cos of 3 pi over 3, which those will cancel. Cos of 180 is minus 1, so this is minus 1 squared, which is 1. So that's part A done. It's very easy. It's at the beginning of the paper. It should be easy. I know in today's date, with the calculators the way they are, people aren't learning angles, trigonometrical angles. So, sine 30, sine 60, sine 45, cos 30, cos 60, cos 45, tan 30, 60, 45. These are ones you should know. Okay, you should know them. If you don't, just based on simple triangle, 30 degrees, 60 degrees, and its sine is opposite, like that. So sine is sine 30, 1/2, opposite over sine 60, root 3 over 2. Cos 30, root 3 over 2, cos 60, 1 over 2. Yeah. Tan 30, 1 over root 3, which is, you can rationalize that. Tan of 60 is just root 3. So that's, how it works. And then with the 45 degree one, these are both 1, and then this is root 2. So sine of 45 is 1 over root 2, yeah, which is, root 2 over 2. Cos 45 is the same, and tan of 45 is 1. So those, effectively two triangles, you need to know those angles. It'll make your life so much easier. Knowing them in this case made this straightforward. But equally, you could put that into your calculator, get the answer, and then square it. Not too difficult, I think, here. Okay, part B. So we've got sum between 50 and 1 of n plus sum between 50 and 1 of cos squared n pi by 3. So first things first, this sum from 1 to 50 of n, a sum of n from 1 to 50 just means 1 plus 2 plus 3 plus 4 plus, and so on up to plus 50. Okay, so that can be done with sum to n terms is a half a plus l. So half 1 plus 50. No, sorry, that's not right. N over 2a plus l, sorry. So that's 50 over 2, 1 plus 50. So 25 times 51. And that is 25 times 51, 1275. So that's the first part of this. And this, because of the plus sign, we can just split it up. Now we need to deal with this second part. Actually, I'll do this separately over here. So cos squared of n pi by 3. So what we've got is cos of, when n is 1, is pi by 3. When n is 2, it's then 2 pi by 3. When n is 3, it's pi. Then when n is 4 pi by 3. So if we think of these, they're going to keep on going. So cos of like pi by 3 is 1/2. Cos of 2 pi by 3 was minus 1/2, and cos of pi was 1, wasn't it? Or minus 1. But because they're squared, they are going to end up being like cos of pi by 3 is 1/2. So that's the first term. Second, a quarter, isn't it? So first term's a quarter, second term's a quarter, third term's 1. Then 4 pi by 3 is cos of 240. That's going to again be a quarter. 5 pi by 3 is going to be a quarter. And then 6 pi by 3 is 2 pi. Cos of 2 pi is going to be 1. So that's the pattern, isn't it? It's going to be a quarter, quarter, 1. Quarter, quarter, 1. Quarter, quarter, 1. So this pattern of a quarter plus 1, that's now, so 3's into 50 goes 16 times, 16 point something. So that's going to be 16 times 3, 48 terms. So this pattern's going to appear for 48 terms. Yeah. Plus, then it's going to be a quarter and a quarter. Okay. Because that's going to be the 48 terms, 49, 50. So this is going to equal quarter plus a quarter is a half plus 1.5 times 16. So that's going to be 24 plus, let me just rub that a little bit out there, plus a half, so 24.5. So my sum to 50 and 1 of n plus cos squared n pi by 3 is 1275 plus 24.5. So 1275 plus 24.5 equals 2599 over 2, or 1299.5. Sorry, it says exact value, so that means as a fraction. So 2599 over 2. And there we have it. So quite easy. Okay. That does have some knowledge of this and the squared. Easy to forget that cos squared, the way you write it, you know, cos squared x is cos x squared. So it is, you know, the way you write it, just being familiar with that. But that's question 3. I think quite easy. Let's have a look at the next one. So as I said in the beginning, 5b was the problem here. This question on trig equations was a good source of marks in part A, but progress in part B was very mixed. Part B is a common type of question on this paper, yet the response was rather varied. Okay, so we'll get on to part B, but let's look at part A first. Show that the equation 3 cos theta minus tan theta times by cos theta equals 2 can be written as 3 sine squared theta minus sine plus sine theta minus 1. Okay, so we've got to show that 3 cos theta minus tan theta times by cos theta equals 2 can be written in terms of sine. Okie dokie. So let's expand. 3 cos squared theta minus tan theta cos theta equals 2. Now we want it in terms of sine. So cos squared is 1 minus sine squared theta. tan is sine theta over cos theta. Cos thetas will cancel there, so this is 3 minus 3 sine squared theta minus sine theta equals 2. Taking it to the other side, 3 sine squared theta plus sine theta minus 1. And that is that. So that was very easy marks there for part A. Very easy. Now let's look at part B. Hence solve for between minus pi by 2 and pi by 2, that 3 cos 2x tan 2x cos 2x. Okay, so first let theta equal 2x. Okay, by doing that, then this is exactly the same as this, isn't it? 3 cos theta minus tan theta cos theta 2. So letting theta equal 2x. So then we've got the 3 cos 2x minus tan 2x cos 2x equals 2. That's going to equal thetas then. So that, well, that'll be just a better way of writing it. The question, then let theta equals 2x. Then in terms of theta, therefore 3 sine squared theta plus sine theta minus 1 equals 0. And now we want to factorize this. Okay, so using the formula, sine theta equals minus 1 plus or minus square root of 13 over 6. And from the angle, because theta is equal to 2x, 2x equals pi and minus pi there, times them by 2. So theta is between pi and minus pi. Okay, so that's going to become quite important. So the positive value of this is 0.449. Does it say any decimal places? I'll do it to 5, to 1, to 5 decimal places. And then or theta equals minus 0.87508 to 5 decimal places. Now between 0 and pi, there's going to be 2 positive answers for sine. There's going to be here, this bit, this quadrant and this quadrant. So this quadrant is going to be 0.44921 and this one's going to be pi minus 0.44921. So I'm going to get that 44921 up, and it's pi minus that. So the additional angle here is going to be 2.69238 to 5 decimal places. Okay, now when I'm doing this, I'm storing these in my calculator. So, you know, I stored this value as A and B, I've stored this value as C, this value is D, this value is E. So I'm just storing them as I go along. Okay, this second one here we'll deal with in a minute, but just while I've got the first the second one in my calculator. Okay, I want to work out what x is. So x theta equals 0.44921 and 2.69238, and it's going to be two more values here, minus 0.87508, and then the next one I'll get in a moment. Let's just move that over a little bit. And then 2x equals all the same values, so x is half of them. So half of the 2.69238 is 1.35 to 2 decimal places. I'll do all these to 2 decimal places. The 0.4491 divided by 2 is 0.224, so it's just 0.22. Or actually, I'll do these to 3 significant figures because that's kind of standard. Now let's deal with the negative ones. Do that over here in pink. So between 0 and going in this direction to minus pi. So we've got minus 0.87508. And this one is minus pi plus 0.87508. Okay, you know what you need to do to this, because minus pi minus this would take me further around this way. So this is what I'm doing here. So in my calculators, minus pi and that gives me minus 2.2665, and divide that by 2, I get minus 1.13, and then get my answer up for this one. Divided by 2 is minus 0.438. So there I've got my 4 answers. I've probably made this a little bit harder than it really needed to be honest. But I do always tend to, if this isn't just a single letter, I always replace this by a single letter and change my range, find the answers in that range, and then substitute back in and adjust. Okay, so find your answers for theta, and then theta is 2x, so divide each of them by 2 and you get your answers in terms of x. So all in all, not too difficult a question, but you do need to be disciplined and use the store function in your calculator. Okay, it's there to be used. It's really, really easy, and do like what I've done here. When I start, when I put these values into my calculator, I put the little letter next to them to know where I've stored them in my calculator, so I can just bring them back up whenever I need. This was minus 2.2665 there. Okay, and that's question 5 done. Okay, question 10. So the examiner noted many students found this question challenging. There are quite a few non-attempts or 0 scores with little to mark. Log 9 to the base 2 equals 3.16 was seen in a significant proportion of scripts. It was generally followed by an abandonment of this question. This could be contributed to a failure to read the given statement at the start of the question. Right, let's have a look at this question. Given that a equals log 3 to the base 2, write in the simplest form in terms of a. So we're going to do part 1. Sorry, just change my pen colour. So log 9 to the base 2 is log of 3 squared, which is 2 log to the base 2 of 3. And this log to the base 2 of 3 is what a is. So this is simply 2a. And that is part A. Part B is log to the base 2 of root 3 over 16. Okay, so that is log 3 to the half over 2 to the power 4. That's the tricky one there to see, because we've got log to the base 2 of 3 to the half minus log to the base 2 of 2 to the power 4. Okay, so rather than 16 being 4 squared, because this is a base 2, think about it, check if it's a 2 to the power something. So 2 to the power 4. So this gives me 1/2 log of 3 to the base 2 minus 4 times log 2 to the base 2. So this is a half a minus 4, because this is just 1. So half a minus 4, which, you know, I think that's quite straightforward really. Let's move on to part 2. So part 2 has 3 to the power x times by 2 to the power x plus 4 equals 6. And give your answer in simplest form in terms of a. So let's take logs. So log to the base 2 of 3x times 2x plus 4 equals log to the base 2 of 6. So this is log to the base 2 of 3x plus log to the base 2 of 2x plus 4 equals log to the base 2 of 6. So this is x log 2 of 3 plus x plus 4 log 2 of 2 equals log 2 of 6. So log 2 of 3, so that's going to be a, so ax plus, and log 2 of 2 is 1, plus x plus 4 equals log 2 of 6. Now at this point I got the log 6 to the base 2 to sort out with. I could really go back to this step, separate this out properly, but if I got to here, then what I really need to do, I've got ax plus x plus 4 log 2 of 2 minus log 2 of 6 equals 0, and this is like that. So really I could have done with this step from here and taken this over, because I need to sort this out first. So our ax and our x are done, and this is log 2, so 16 over 6. because minus in logs is dividing them. So ax plus x plus, so 16 over 6 is 8 over 3. And there we have it. So log 2 of 8 minus log 2 of 3. So that was the step I was missing. 8 is the same as 2 cubed. And this is just a. So we've got ax plus x plus 3 minus a equals 0. So that is factorising out the x, a plus 1 equals a minus 3, taking that to the other side. So x equals a minus 3 over a plus 1. So I had to do a little bit of a pivot in between in doing this. Sometimes you'll have to do the same. You might have to go back a few steps. I could have, at this point split this one up as well, because this is going to be 2 to the power x times by 2 to the power 4. So split it up into 2 logs there and gone from it that way. But the trick is, even once you get down to this point, remembering that 4 you can put back into a log. Okay, and because you want log to the base 2, log 2 to the base 2 is what you would use, 4 times that, or taking it up as a power. So that is part 2 done. I think that's pretty much it. I could have, again, like I said, done it slightly differently. There's a lot of ways in which you can manipulate logs and powers, but this is how I did it, with a little pivot in the middle. So that's the end of the October 2022 questions. Now, if you've found this video useful, please like, subscribe if you haven't already done so, and like I said at the beginning, if you're able to help or want to help me out a little bit, just consider becoming a member, even if it's just for 1 month. See you on the next one.